Okay, I was supposed to have a conversation with Peter H, except that he's not able to right now. He said maybe tomorrow. He's um he's pretty bright, atheist, intelligent guy. But he was questioning me on the speed of light, and of course, we know that the speed of light is measured to be. We can actually measure it. He gave me a video that talked about measuring the speed of light. We can actually measure it, and it turns out to be about 300,000 kilometers per second. But that's in a vacuum with little resistance, and it's where we're at. So it's not exactly instantaneous, but it's pretty fast. Okay, the only thing is my speculation is that we're not actually seeing the actual speed. The reason I believe that is because depending on where you are in the universe, it's going to be a different speed, and I could explain that pretty easily. And so it's always, I'm used to 186,000 miles a second, but it's always that speed with those measurements. 186,000 miles in 1 second. Okay, it's always going to be that rate, no matter where you are in the universe, no matter what. Okay, except that when you go to a place near a black hole, your time is going to be dilated and your distance is going to be dilated more than what it is where we are right here. So what's the result of that? The result of that is that your second is going to be faster. So instead of being 1,001, it's going to be like 1,001. And your distance, instead of being 186,000 miles, is going to shrink so that when you measure the speed of light, it's going to be exactly the same as what you measure it here. It's going to be 186,000 miles, which is a shorter 186,000 miles. And it's going to be 1 second, which is a faster second. So how's that going to work out? So the time dilation makes the second longer. So instead of being 1,001, it's going to be a 1,001. That's 1 second. So it's going to take longer for light to travel less distance, relatively speaking. So if you look at the speed, and you can imagine if you put let's say you put, make a measurement about, about so wide or whatever wide, and you say that's the distance, 186,000 miles. So now look at the rate of the speed of light as it passes from point A to point B. When your hands are apart, it's going to be 1,001. So you'll see in that amount of time, you'll see the light travel fast. It'll be 1,001 from point A to point B. Then when you get close to a black hole, put your hands together, and it'll be a shorter second. So it'll be 1,001. I mean, it'll be a longer second because time slows down. So it'll be 1,001. So you can actually see the light even when you put your hands together. It'll take longer for light to get point A to point B when your hands are close together. So it'll be 1,001. So you can actually almost see the light traveling from point A to point B real slow. 1,001, and your hands are close together. Now let's say we're away from any black hole, and so you put your hands way, way far apart. Put them like, a block over there and a block over here from point A to point B, and your second is going to be real fast. Instead of being 1,001, it's going to be 1,001. So now the light is going to be closer to the speed of light, the actual speed of light. I mean, the actual instantaneous speed of light. Now, my question is, which is the right speed of light? Are we seeing the actual speed of light? And if so, how can the speed of light be different in different places? And which one is the right speed of light? Is the right speed of light what the photon experiences with no gravity? Because we're affected by gravity. Our time and distance is affected by gravity. But the photon is not affected by gravity because it doesn't have mass, doesn't have any mass. So it really doesn't matter to the photon how much gravity there is because it doesn't have any mass. So it's always going to travel at the speed of light, which is traveling, taking no time to travel no distance. So it's already, in special relativity, it's already there. It just can't arrive before it leaves. So my question is are we actually able to see the right speed of light? Considering that we exist in a dilated fabrication of time and distance, and it depends on where we're at as to how fast the light is traveling. And if you get real close to the black hole, the photon's hardly moving because the second is lasting so long and the distance is so small. So it's hardly moving from point A to point B. So tell me, which is the right measure to determine the age of the universe? I would suggest that none of those are the right measure to measure the age of the universe because they're all disagreeing with each other as to the passing of time and the measure of distance. So that's basically my point for Peter H. whenever he shows up. He talked to me before about evolution, and of course he's been talking to me for years now. You know, he really thinks I'm crazy for being a creationist and believing in God and all that stuff, trying to convince me that the scientific method is right and Bible teaching is wrong. So that's my question: is like, which rate of the speed of light is the right rate when it's clearly moving at different rates, different speeds, no matter depending on where you are in the universe. Sure, we measure it where we're at right here, and it's 186,000 miles a second, 300,000 kilometers per second. That's because everybody's making that measurement right here in this frame of reference of the rate of time where we're at and the measure of distance where we're at. Problem is when you're I just got back. Yeah. So the problem is that when you change the measure of the second and the measure of a distance, your parameters for determining the speed of light, that's going to change the speed of light. Because remember, Einstein said it doesn't change. It's always going to be 1 second for every 186,000 miles or 300,000 kilometers per second. No matter what, that's the rate of the speed of light. The problem is that if you move away from any black hole where there's no gravity, your second is going to be much faster, because remember, it's the gravity that dilates time, it slows down time. So if you're away from any gravity from a black hole, hypothetically speaking, if there is such a thing, so your second is going to be really fast. It's going to be 1,001. And your distance is going to be really huge because it's not being dilated by time or distance, by gravity. Your distance is not being dilated. So your distance is going to be greater. Your 186,000 miles is going to be a greater distance. So that the speed of light is actually going to be closer to instantaneously than it would be if we measured it right here, or if we measured it near a black hole. So the question is which rate of the speed of light and which rate of the passing of time is the right rate? And I would suggest that it's the special relativity rate for the photon, because the photon's not affected by gravity because it doesn't have any mass. So it doesn't matter, because what we observe is affected by gravity and mass. Our time slows down and our distance decreases with the gravity from mass. But for the photon's not affected by that because it doesn't have any mass. So it travels no distance. I mean, it arrives instantaneously. In special relativity, it arrives instantaneously. It just can't arrive before it leaves. So I would suggest if there is a correct speed of light, it would be the special relativity rate that the photon experiences traveling at the speed of light, where distance becomes no distance and time becomes no time. So it takes no time to travel no distance in special relativity. So that would be my question that I would present, because you can't have conflicting speeds of light. You can't have one speed of light over here, another speed of light over there. Otherwise, what you're seeing is not valid. What you're observing is not valid. It's just like when light's bent and you're not seeing the stars where they are, or you're seeing a kaleidoscope of the galaxies, the same galaxy, in a kaleidoscope area. You're seeing the same galaxy, but the galaxy in reality is only in one place, not in many places. So which is the reality? And I don't believe that we're seeing what the reality is when we go to measure the speed of light, because of the fact that we get contradictory measurements depending on where we are in the universe, according to relativity, general relativity, and the effect of gravity on time and distance. It wouldn't matter if the parameters, your frame of reference, and the parameters of a second and distance remain the same, but they don't remain the same. Distance becomes shorter near a black hole, and time slows down so that your second is a lot longer. And that results in a slower speed of light. It's not complicated. Just got to listen to some jungle jargon once in a while.